Hi everyone and welcome back, and this video is about the changes that happened in the lab. So yeah, title is what it says. Now before we go into the new bibbly bobbly bits that we've got in here, just like to apologise to some people that I haven't been able to give any feedback or any comments to from the messages that you've been posting on some of the videos. That's because it's happened to other people on YouTube as well, but we're having trouble leaving messages for some reason. You type in a message, say yeah, thank you for the comment, or blah blah blah, or this is what you got to do, and you hit the post button and it says failed to post and what have you, or comment can't be uploaded or something along those lines, and it makes us look like a complete total arse because it makes it look like that we're ignoring you when we're not, and it's actually the fact that we can't post anything at the moment. Yeah, so I'd just like to say apologies for that. It is in the hands of the YouTube Google guys at the moment apparently, and they are working on it. I don't know when it will be fixed, but some of my videos I can post comments on, some of them I can't, some comments I can do on certain videos, some of them I can't do it on the same video but I can on others, and yeah, the whole thing's a complete mess. So if it looks like that I'm ignoring you, I'm not, I am here. It's just that I can't reply to you at the moment for some obscure reason. I believe it's something to do with their spam filtering and whatnot, I don't know. Right, anyways, moving on. Changes that we've done. Right, well, we've got in some new kit. We've got in some new soldering irons, some new microscopes, the new DMMs. The MSc kit has turned up that I'm going to show you, ones that are normally in the hands of postgrads after they've been raiding our lab. Yeah, that stuff's back, so I'll show you some of those bits which I've never shown you before, and a couple of other bits and bobs. So yeah, let's go mobile, and yeah, I'll show you about the place, the kit that we got. Right, well then, first things first, down on the bench, Benchtop Multimeters. Now I mentioned these before, I can't remember whether we had them in or not in the last time I've done one of these videos, but these little boxes down here, the Rigol DM3058s, these are now on every bench. Benchtop Multimeters, they've replaced the handheld ones that we used to have, the flukes. We still use the flukes if you need to use 2 multimeters, but yeah. These ones are here to stay. If we switch this on, there we go, it takes a bit of time to start up. These particular boxes have all the same functions as your standard handheld multimeter, things like measuring voltage, current, ohms, continuity, diode, capacitance, currents and what you're not. All the same functions, but it does have a couple of extra options and they are far more accurate than your handhelds. These measure down to the into the microvolt and the nanoamp scale. It's got 4-wire measurement for your resistances, so you can either switch it to 2-wire and you can treat it like a normal handheld DMM, or you can switch it into the 4-wire mode where you can apply current, you measure the voltages, and it gives you the resistance from that. So measuring low resistances using the 4-wire measure method is much more accurate, so you can do that on these. Also gives you the ability to measure both your voltage and currents simultaneously using the second function. So if you want to profile any power supply going to your circuit over time, then you can. These are all connected to the desktop computers via USB, but they also can be connected via Ethernet and GPIB as well. So again, if you are doing your power monitoring to your circuit, you might be doing monitoring your power consumption from your cell or from your battery or something like that over 24 hours just to see how it operates, or under different conditions and so on, different loads, then you can do this over time, so you can log all your data to a desktop while you're measuring voltage and current at the same time, get what you're reading, is plot out the data, and you can see exactly what's going on in your circuit over 24 hours, 48 hours, or however long that you want to record your data for. So that's those. Like I said, these are the DM3058s. They're not the E version, they are the top of the range ones, the E, denoting the educational version, I believe. And with that, you only get the USB connectivity, but on this one, we've gone the whole hog. We've got a really good discount on these. So yeah, you got the top-notch version of that particular type. Moving on, desktop computers have all been reinstalled with the latest software. Still Windows 7 predominantly, simply because hardware connects nicely to Windows 7. Windows 8 and Windows 10, there's still a lot of hardware problems with interfacing stuff. Some of our first years have found that out when they're trying to connect their MIDACs with Multisim and LabVIEW and whatnot, so that's why we're still Windows 7. Like I said, all the kits all hooked up to the computers, so you've got remote connection to those, and you can upload and download data, whether it be from the scope, the arbitrary signal generator, or the DMM. Right, moving on down. Let's go down the bottom of the lab now. Okay, on the trolley there, UPS that I pulled out from the machine room. Do a tear down on that at some point. That's another one that failed, reached end of life. Didn't catch on fire like the other ones, that just tripped out power. Now then, down here, soldering area. You might notice first of all, yes, we are going lead free in this lab. First stage of that is getting rid of the leaded solder, getting in the green lead-free solders. So that's our first stage, and also on top of that, we've got ourselves some new irons, some metcals, which are lead-free, and this is lead-free zone now. Down this end, completely lead-free, so lead-free irons, lead-free solder, working with lead-free circuits. And on top of that, we've got some nice new scopes. So first of all, scopes made by Vision Engineering, top-notch ones. Got two of these. These are the Mantis Elites. These particular ones have the HD camera built into them, so you can view what you're seeing in your scope on your desktop as well, if you really must, so you can show off exactly what you're doing. It's always good to, we've got that function so that we can show how to solder components. So if you've got tricky SMA devices and stuff like that, we can show you how to do that on a big screen. These particular scopes that we've got on the long breech arm, so you can cover the entire desk. Down here we've got various lenses and the lens protectors. Lens protectors definitely come in handy, since that when you're soldering you get all that flux residual billowing off your board and whatever. You don't want those getting onto your nice expensive lenses, so they're all lens covers. This particular, if you're not familiar with a Mantis range, these are stereoscopic microscopes. As you can see, there's no eyepieces on this. There's only one eyepiece. That's the viewer, what you look directly through. So hey, hello, you can see me there. Right, yeah. Yeah, so you don't have to pressurize up against any small little apertures. You can work comfortably at a nice distance. Like I said, the stereoscopic, what that means is what you see is basically 3D. You get a realistic 3D view of your component. You can see the side profiles going down the side to your components. You can see the plane of your board. You can see your joint as it angles in nicely, and it makes working with your components a hell of a lot nicer, because your eyes aren't really pressed up against the your little viewers or anything like that. There's no eye strain really using these, and they're really nice units all around, and they're used everywhere. They're prolific in every form of science and engineering. These are the top of the range microscopes. I do like them. The only thing that I don't like is the connectivity of the camera internal. It's on these stupid little piddly little connections at the rear, and there's no as you can see, there's no actual hangy things or any P-clips or any channels or anything to run your cables down. They're all bloody loose, which is, I absolutely hate it. So what happens is, if you're not careful, you can snag on the cables and rip the sockets at the back of the bloody scopes. And that's a really bad design, you know, putting on a very delicate connector onto something that's going to take a bit of a beating. Pain in the arse. Anyways, the lenses that we've got down here on these, we've got 2 different ones mounted on each of these because we've got 2 of them. There's the other one with the cover on. We've got a long working distance ×6, and if you're spinning around you've got a ×10, so you can work from a distance, solder your board up, you know, you've got a nice bit of room to work under, and then you can move into the ×10, get it closer, and you can see a little bit more in detail and check your work and what you're not. Right, moving on from that, because that's enough of that gibberish. The soldering stations that we got. Alright, I'm back. Sorry about that little blip then. Camera just said that I ran out of room, so I had to delete some videos on here. Anyway, back again. So, where was we? Right in, yeah, soldering stations. We've got 2 of these in, dual channel down here, Metcal soldering stations. These are the MX 5200s. Basically, these ones are more or less what I call hands-off soldering. There's only one control on this unit, that's this little push button here. If we switch this on, you can see this, might be able to see this a little bit clearer. Sorry for the very dim view on this video. For some reason the lighting in this lab is not 100% today. Yeah, anyways, these are the MX5200s. The only control that you got is this button here. Hold it in, it brings up the menu, and if you just tap it, it switches in and out, whether it's a dual channel or single channel, and so on. No temperature setting to be done. You can work with a default temperature, which is lead-free soldering, which is perfect for us. And so just switch it on, select both channels, and off you go. The soldering irons are cold start soldering irons. These ones are also known as RF soldering irons. Basically, as soon as you pick up the iron, it gets hot. As soon as you put the iron back into the holder, it goes cold. And the time it takes to heat up is that quick. It's ready to solder, and it cools down relatively quickly as well. That means, yeah, you're saving on power, you're saving on tips and everything, because they're not permanently on. And yeah, so on this particular iron we've got the micro tip on that one, tweezers for desoldering, and then same over on this side. We'll move that out of the way. Got the same thing, we've got another one set up there, which is on power save at the moment because someone left it on overnight. Yes, they do go into power save, which is a good thing, nice and green. So down here again we've got different soldering iron. This one is a solder sucker, so no more using the little pump charge ones. You can desolder your components using a proper desoldering iron. And another one with a tip, big chunky one for any shielding or grounding or anything like that that needs to be done. And should you need to do any very delicate work, we've got ultra fine tips. They're just there for any touch up S&D stuff. They're all push fit basically, just on and off the irons. So they're really good, and they're wonderful little irons they are. Since we've had them, I had no trouble. Like I said, there's no temperature control. All the temperature settings are done with the actual tips. So remove the tip, slot in a new tip, you've got a different temperature profile. So just select the tip that you need for your particular job, and the machine does the rest really. It's they're very simple, very easy, and like I said, they do switch off when they're in the cradles. That means that yes, the tips are that bit more expensive, but the lifetime is a lot higher than the standard tip because they're not on all the time. And if the irons are left on overnight, then yes, the boxes do go into power save to save on lifespan of your iron, so even if they are expensive, you know, you're not going to kill your iron. Other stuff that's happened down this end, compressor that used to be in a workshop is now in the lab because we've now got a dedicated air line in the workshop. So I brought in a compressor from the workshop, running an air line around here for the desoldering gun and to a air gun that we've got down here. So if you need to blow off your circuit boards or anything, clean out any particular devices that might be a bit dusty, then you can do that. Other stuff that's gone on, we've got a solder paste stenciler, so you can put your stencil in the top there, hook it in place, place your board onto the bed down here, and you can swipe your paste through a solder mask. So thumbs up, so you can paste your board, bring it over here, you can populate it, hand solder it, or you can populate it, whack it in the small oven, unless you're working on a panel, in which case you can use the big oven over there, or you can pick and place if you really want to. Other stuff that's been going on down the far end of the lab, so let's take it all down there. Right, and down to the bottom end of the lab. This is an experiment that we've been working on at the moment. I'll try and zoom in on one of these. Yes, it's not, we've got Evian bottles in here, but it's not, you know, promoted by Evian or anything like that. It's just those sort of bottles that fitted quite nicely. Anyway, this is for our IEP, our Integrated Engineering Program. This is an experimental board based around a bioreactor. It's meant to be, but it doesn't have to be a bioreactor. Basically, it's a mixture of chemical engineering, because you're mixing different chemicals in the beakers at the rear. It's mechanical engineering, because you're dealing with motors and gearing and what, you know, is to do with electronic engineering. So you've got your circuit board down here, you need to build control circuitry to control your motors, things like that. A little bit of sensor and heating going on, so you've got a heating element in that particular beaker to heat up a liquid with a thermistor to provide feedback, so you're monitoring temperature, so you've got to work with power electronics, so high current and what have you, to controlling your heaters. pH sensor, which you have to design a circuit around so you can measure pH of your liquids, and you've got your motor there, so you're looking at PWM for controlling your motors and what, you know, and various, you've got some pumps down there so you can pump your liquid in and out of your various containers. That's really mixed engineering, and that's all done as a group project. Had to make up 20 of them, and we're still working on it now. Last year this was running, all the beakers are separate, and the pumps weren't on the balls, you didn't have a power supply board, everything was wires everywhere. This year we're going to step more, and we have really tightened it up nicely into trays, with the power distribution board already on there, which is fused, so if anything does go wrong you can switch in and out, you know, switch on and off your supplies, and should you draw too much current, the fuses will pop. You're not going to kill anything. Seems that you are dealing with high current for your heaters and your motors. So moving on from that, other stuff that's going on, computer cluster upstairs is being used as a overspill for project students and you know, scenario work. So what we've decided to do is getting a bit of kit for upstairs. So we've got onto Lambda, they've got onto Picoscope, and we've got some nice Picoscopes for upstairs. These are 3000 series, the MSO, so you've got a digital analyzer, oscilloscope and function generator. They'll be upstairs as and when you need them, sitting on the benches. So if the lab down here is full, which it is, we've got a complement of 130 undergrads this year, so that is this lab completely chock-a-block on Thursdays and Fridays. If you need to work elsewhere, we've now got those. We've got 40 of them, one on every bench upstairs, and yeah, you can continue your work. The only thing you don't have is your power supply, but there's nothing to stop you from running your stuff off battery upstairs. So you got DC, your DC source, you got your signal generator, you got your scope, you got your digital acquisition stuff, all there. they're going upstairs. That's 40 of them. And that just brings us to a little bit of a show-offy of the MSc kit that just normally goes wandering in this place, because it's very, very useful. So what have we got? We've got RF network analyzers up to 3 gig. We've got signal generators up to 3 gig. So the signal generator is Agilent, which is now Key. That's the E4432B ARB. RF network analyzers, 8714 ETs. We're looking at replacing these next year, because yes, they are floppy drive driven. They are donkey's years old now. They're getting on a bit. One of them, we've got 2 of them. One of them is going out of calibration now, so they need replacing ASAP. So we'll probably be doing that next year, so you'll see those. Other stuff that's not normally here, which is here now. Vector signal generator and signal analyzer, both done by Roger and Swartz, bought as a pair. Can go up to 6 gigs on those and up to 13 gigs on the signal analyzer. The VSG, the vector signal generator, is the SMB V100A. The signal analyzer, what model is that? It's the FSV series. Either I'm going blind or I can't see the model number on that, but yeah, both done by Roger and Swartz. If I find the model number, I will let you know. It's probably written on the back, but I can't be arsed searching for it now. Over here, other stuff which normally isn't here, that you don't normally get to see, but it is back now. Tektronix MDOs, mixed domain oscilloscopes. They're the 4104s. 6 gig real-time spectrum analyzer, up to 1 gig 4-channel scope. You can mix both the RF and the time domain, you know, not mix it, but you can show it together on the screen in real time, so you can split screen, see what you're doing in the time domain and the frequency domain, so you can monitor, you know, your RF outputs while you're looking at maybe timing inputs, or you know, your analog inputs that you're modulating for your RF out and all that kind of stuff. Both of those are up here, and we've also got all the various decode options, so you can plug in a pod and then decode the various computer inputs, things like USB, I2C, SPI, you know, parallel serial comms. You've got other ones which is embedded communications. Another pod which we've got is the RF one, which means that you can trigger off the RF channel instead of the time domain channel. So if anything's happening, you know, getting any glitches on the RF side, you can trigger on those glitches and see what's happening in the time domain in various other sections of your circuit. So yeah, we've got all the options for those. Oh, I'm running out of breath. Alright, down this end, 2 bits of kit which you don't normally get to see. We've got an Infinium S series DSO 604A digital storage scope. Again, 4-channel one, loads of bandwidth. Top end is up in the gigs, I think it goes up to 6 gigs. You can see it there up the top. So yeah, it's a 10-bit DAC, 20 gigasamples a second on that one. So yeah, high spec, high and everything. That's that one. Bitalizer. Now then, I don't think over there, just on the shelf in the middle of that, you can just about see it on the top of the bench, just above those green boxes. That's our old bitalizer which failed. We got a new one in, an Amritsu one. We've got a new BERT. That's the MP2100B. So you can look at the bit errors over fiber. So you basically set up a fiber system, and you know, you can measure the error. Down here we've got some other bits and bobs that aren't normally here. Optical spectrum analyzer, so you can shove in your signal from various optical sources. So these are ones that are made up. So you've got DFB, laser, you've got February Peri, you've got a another one there, a 3010, well, wavelength is 3010 pigtail laser, which is in there. So various comms lasers and LEDs can be monitored on that. That's one experiment. This one you've probably seen knocking about a lot, but we're looking at getting a new one of these as well, light wave component analyzer. So very similar to the RF network analyzers, but that's combined with these pods on either side. So you've got a laser transmitter and receiver. So same thing as the optical one, so you can do bode plots and stuff like that. As frequency sweeps, it displays the characteristics of your system on the screen. And that's really the big changes that have happened over the course of the summer and last year. Probably seen some of that stuff already. Been doing these, and we've changed things up so much that I'm losing track of what's actually happened during the year. Probably come across something else later on that I'll let you know. And yeah, that's our old Bert that failed. It's gone completely dead. I did try and strip that down and do a tear down of it, but camera played up when I thought I was recording. I wasn't recording, and yeah, that just fell apart in the end. So I couldn't really post that one up. That was a bit of a failed recording, unfortunately, because that was a good little tear down. This power supply in there, that's actually shagged, but it's a custom made supply with a secondary control board on there for the power supply, which is also another custom made jobby. So yeah, that really was a pig to try and fault find on. Might do that one again at some point if I get a chance to do it, but it was a long haul video. Anyways, yeah, I will leave you with that, and yeah, see you next time.